All right, guys, today we are going to actually use our standard form to graph. The last couple of days we have been talking about and practicing how to find all the intercepts, X intercepts and Y intercepts. Now today we need to use that information to then help us find that key point, which is that vertex point. We can't graph a quadratic, aka gives us a parabola, unless we have the vertex point. That is a key point. Just a little recall for us, guys. A standard form of a quadratic. We do have that x squared term. Then we have that x to the first power. And then we have our constant there. So different from our vertex form we've been working with. You're like, Miss Golly, how do I know if I can solve with square roots versus doing our factoring thing? It all depends on the form. Vertex form, the x is being squared. And we don't have any other x's in our vertex form. So if you've got more than one x, you're going to have to go with your standard form. All right, letter A, it asks us for concave up or down. We're going to get to that in just a minute. Let's start with, though, the piece we've been practicing. What I want you to do is just take a minute or two, find the x-intercepts, and go ahead and find the y-intercept. That's the pieces we've been practicing. As you're trying it at your seat, I'm going to go ahead and write the steps up here. Or if you still need to follow along with me, you can. But this is the piece we've been practicing. And on this first one, you see a plane x squared. So I'm just going to make a little note here. You don't have to write shortcut, guys, every time you use it. I'm going to just write it up here for the sake of notes. But it's a plane x squared. I can use my shortcut. So multiply to get -8. Add to get 2. How much of this beginning work you show, guys, that's up to you. You don't have to write shortcut. It helps me to write my two numbers down. It helps me to show that, but all that beginning stuff, that's up to you what you show. The part that I need you to show is the part where you've actually factored. And remember, the order doesn't matter. If you put the +4 first or the -2 first, you have to have, though, it has to be a +4 and it has to be a -2. Otherwise, when you add them, you don't get the +2 we need. And then the other piece then is actually finding those x-intercepts. We set each piece equal to 0. So this is the part we've been practicing. And as we've been practicing them, I know we haven't been putting them on the graph yet, but I've been encouraging you guys, write them as ordered pairs. So then when we do go to graph, we know exactly where they need to go. Those are our x-intercepts. So this is the piece we've been practicing. And then I know the y-intercept isn't until part E, but it's what we've been practicing. So if you want to go ahead and find that, you can. Most of you I know on your assignment yesterday are like, Miss Golly, do I have to show any work for that y-intercept? No, guys, you really don't. If you need to show yourself putting the zeros in for the x's, and if you need to put this in your calculator, you can. But all those terms with 0, well, they just become 0. So our y-intercept is just that constant. It's just that -8. So these are the pieces we've been practicing. So far, nothing new for us. But having x-intercepts and having a y-intercept, I can't make my parabola without my vertex. So that's what our focus needs to be on today, is finding that vertex piece. So to start, to figure out how we're going to get that vertex, what I want to do is go ahead and graph our x-intercepts. So we have one at 2, and we have one at 1, 2, 3, -4. we know, after all the work we did last unit, we know that our graph is symmetric. So I know that if I fold my graph in half, those two x-intercepts need to match up. If I fold my graph in half, those two x-intercepts need to match up. And the place where I fold my graph in half, guys, that's the axis of symmetry. So where's the axis of symmetry at in relation to these two x-intercepts? Where's it going to be? It's going to be right in the middle, right? And somebody already said it. Where did you find it at? -1. So let's see. So that would be, let's try it out. Somebody said -1. I'm going to put my axis there and let's see. So that axis is 1, 2, 3 spaces away from 2 and 1, 2, 3 spaces from -4. Now if you're like, whoa, wait, so I'm going to have to graph this to figure that out. You don't have to graph it. So we found our axis is x equals -1. You can count it on your graph, but like we saw yesterday and even the day before, sometimes our x-intercepts are not integers. We were getting some fraction x-intercepts, so I don't know if it's going to always be the best to count. So if I want to find the middle, here's a really quick, easy way to do that. Add your x-intercepts together. Add x-intercepts. And divide by 2. If you want to find that middle really, really quickly, and you don't want to have to graph it, you don't want to have to count it, add your x-intercepts together. So we have 2 plus -4, and we divide it by 2. So -2 divided by 2, there's our -1. That little trick is going to come in handy, and we'll see it today in this lesson, where our x-intercepts, they're not nice integers. Sometimes we get fractions, sometimes we get decimals, and it's going to be hard to count to find the middle if we have a decimal or fraction we have to work with. Now, the thing I want to caution you on with this, if you're going to put this, sorry guys, this is touchy today. If you're going to put this in your calculator, let me just show you real quick. You're going to need some parentheses in there. Oh, there we go. If you don't put parentheses in there, let me show you the difference with what happens as soon as this decides to load for me. Sorry guys, it was loaded. My computer restarted itself this morning. All right, so here's what we have. We have, what did I put first on there? Let's see, 2 plus -4. So if I just do 2 plus -4, and I put divide by 2, I'm not going to get -1. Your calculator does order of operations. That calculator is going to do -4 divided by 2 first, and then it's going to add the 2. Your calculator does order of operations. It doesn't do things in the order you enter them in. It does order of operations. So if you're going to put all that in your calculator all at one time, you have to put parentheses around that addition piece. So the calculator does that first. The calculator will do parentheses first, and then divide by 2. So my advice is I would just do it step by step, like I did on here. I did the numerator first, and then I divided by 2. If you're going to put all that in your calculator at one time, you need to make sure that you use parentheses around that numerator. Otherwise, we just saw the difference with that order of operations. All right, so if I know my axis of symmetry, I know my vertex is somewhere on that line. Now, last unit we worked backwards. We knew the vertex and then we got the axis of symmetry. Let's go the other way. I know the axis of symmetry, so that means I know the x of the vertex. I know, again, last unit we picked out the vertex, and then from that we got the axis of symmetry. Well, we can go the other way too. If I know the axis of symmetry is x equals -1, that means my vertex also has an x of -1. We can go the other way, and that's okay. Now, if I know the x value, and we've done this before also, if I know my x value is -1, substitute it in for x. Substitute it in for x to get your y. This is the same thing we do to find our y-intercept. For the y-intercept, we know x is 0, so we put 0 in for x and we solve for y. Same thing here. I know my x is -1, so I put -1 in for x, and I'm going to figure out my y. Same as when we found our y-intercept last unit, even this unit. If you don't want to battle through that computation, guys, use the technology we have. No problem. We've got -1 squared plus, let's see, 2 times -1, and then we have -8. So you can put that right in your calculator. If you don't want to go through the order of operations, I'm not assessing you on order of operations, guys. I'm seeing if you can find a vertex. Please make sure, though, all those parentheses need to be there. If you don't put parentheses around the -1, let me show you what happens here. We get a -11. If you don't put parentheses around the -1, what the calculator does is it squares the 1, and then it makes it negative. Okay, so you have to make sure parentheses. Yes?
If we can use the axis to symmetry for x and vertex, why can't we use the y-intercept?
All right, so we put that in. We got y equals -9. So our vertex, we need that middle point. The axis of symmetry gives us the middle of our graph, but now the vertex gives me exactly where that, in this case, minimum point is. We've also seen it be a maximum. And then now the y-intercept, we can go ahead and graph that. That's at -8. And then we reflect it over. So the x-intercept and the y-intercept, guys, that can give us 4 great points on our graph. But we have to have that middle. That vertex point is our key point. That's our have to. That's our have to. And then now we have a nice looking graph. Domain and range, here's the cool part. It's the same as last unit. This is the same looking graph we had. So domain is all reals. Our range, our graph is opening up. So we have y is greater than or equal to, and it's still just that y value at the vertex. That part hasn't changed. A lot of these things, they haven't changed for us. All the pieces of the graph are the same. How we get them is a little bit different, okay? So for this one, and I know I put it up at letter A, the concave up or down. Is this one opening up or down? Which way are we opening? We're opening up. Here's how you tell. Here's the cool thing. Look at our standard form. The A value you see there, guys, that A value does the same stuff that it did in vertex form. So if that A value, so if A is negative, that equals a reflection. If A is negative, actually, you know what? Let's put that up here. Sorry, guys. Let's put it right up here by A. If A is negative, that equals reflection. If A is negative, so if the number in front of x squared is negative, we're going to get a reflection, same as we would have in vertex form. And in vertex form, that was also an A when we did just our generic notes for that. So this is going to be up. A is positive. Or if you don't like using A, number in front of x squared. A is the number in front of x squared. If you don't like using just that generic A, that's okay. So that's going to tell us how our graph should look. We don't have any of the other transformations. We don't know if we're going to go left, right, up, or down. We don't know that from this form. But we can know whether we open up or down. And that's important to know. At least we have a general idea of how our graph looks. So all these pieces, again, they're the same where we find them on our graph. The relationship between the axis of symmetry and the x value of the vertex. The relationship between the y value at the vertex and your range. Okay? So all I want to do then today, we're going to do a few more examples together because I want to show you how to deal with those instances where we do have some fractions or some decimals that we work with. Our process isn't going to change. I just want to make sure we're okay with graphing it. All right, so let's go ahead on to number 2. And let's get used to figuring out if we're going to open up or down. So are we going to reflect or not? We look at x squared. X squared, it's positive. So we're going to open up. If you want to write another note to yourself there, number in front of x squared is positive, you can. Or if you want to write no reflection, that's up to you. And remember, when we talk about that, I should have drawn the pictures last time. It's not whether or not our graph moves up or down. I think some of us were confused on that last unit. It's how it looks. Is it opening up like a U shape or does it flip upside down? All right, so let's go ahead and find our x-intercepts. Most of you have already started on that on me. I think half of you are on the axis of symmetry already, and that's okay. I'm going to just make those same little notes up here. We have a plane x squared, so I can shortcut. How much you write out here, guys, again, it's up to you. Remember, it does matter which one's negative. It does matter if the 7 or 4 is negative. We have to add to get that positive 3. The order you do those in doesn't matter, but the 7 has to be positive. The order you go in, it doesn't matter if you want to jump over and do the y-intercept before your axis of symmetry and vertex. It doesn't matter whichever way you want to go on that, guys. Axis of symmetry, if you want to graph your x-intercepts and try to count, you can. I recommend for the axis of symmetry, add your x-intercepts together and divide by 2. Add your x-intercepts together and divide by 2. That's going to be the easiest way to find where that axis of symmetry is, aka the middle. We've got to find the middle so we can find the vertex. The vertex is the key point of your graph. We can't graph without it. We've done graphs without x-intercepts. We've done graphs where we didn't graph the y-intercept because it was really big compared to everything else. But we have to have the vertex. We have to have that middle point. Now, for your axis of symmetry, this one does end up, I get negative 3 over 2. I want to make sure I talk to you about this today. especially before you do practice on your own. Guys, it doesn't matter if you want to write that as -3/2 and leave it a simplified fraction, that's fine. If you want to make it a mixed number, that's fine as well. I am also okay with a decimal as long as you don't have to round it. So this one is just -1.5. So it's a terminating decimal. I don't want you to turn it into a decimal if it's something you're going to end up rounding. We want to have exact answers. So I would accept any of those three ways. You choose what you like. I know most of you will probably choose the decimals, and that's okay as long as it's a nice decimal that terminates. So -1.5. So I go over 1 in literally a half of a space as best as I can. You don't have to do anything special with your x scale. Just go in between -1 and -2. Now, when you go to find the vertex, you already know the x part of it. We have to find the y. So if I know x and I want to find y, I substitute in for my x. The easier choice when substituting in is going to be the decimal. It's going to be the decimal when you substitute in. So we're going to have, again, make sure you have your parentheses. We're going to substitute in -1.5 for our x's, and that's going to give us our y. So finding the vertex can go pretty quick. Add two numbers together, divide by 2. We've got the x part of it. Substitute in for x. It's a little bit of plug and chug in the calculator, and we're good. So I will show you again how to enter that. Even my basic calculators, like Miss Golly, get the graphing calculators out. I don't need to, guys. These calculators that I have up here have parentheses on them too. So you don't need anything special. So -1.5 squared plus 3. Again, guys, use your parentheses. I would get away from trying to use the multiplication symbol. -28. Again, it'll just take not even a minute to enter that into your calculator, and you're going to have the other part of your vertex. So -30.25. Oops, I need to make that a little bigger. Now, before we graph, let's go ahead and find our y-intercept so we make sure everything fits. We already have a -30.25 that we're going to have to fit, so we know we're going to have to change our y scale. But let's make sure that our y-intercept will fit on our scale as well. The y-intercept, guys, again, if you need to, I don't have to see this work. I don't have to see you put 0 in for the x. The y-intercept, it's just that last number. It's just your constant, the one without the variable. If you need to show yourself the zeros and you need to put that in your calculator, I won't stop you. It's up to you. All right, so let's get all of our pieces on our graph. We already have the intercepts. We already have the axis of symmetry. But now I have to fit -30.25 on the y. It only goes up to 10 spaces, so I can't go by 2s. I can't go by 3s. What do you guys want to go by? Should we go by 5s? Go by 5s? Okay. All right, so I'm just going to make a little note here. We're going by 5s. Try to make your scale as small as you can. Like if 2s will work, go with 2s. If 3s will work, go with 3s. We don't want our graph smashed down. But with this one, we don't have a lot of choice. All right, so I'm going to change. And we talked about this last time. If you don't have the space, I know these graphs are not very big. And I'll blow mine up here in just a second for you guys. My scale is going by 5s. I know, but Miss Gal, it looks like it's going by 10s. There's not a lot of space on the graph. So instead of my trying to label every little line and have a ton of numbers smashed in there, I'm still going by 5s, but I labeled every other line. So I labeled the -5 line with -5, but then I didn't label the -10 line. There's just not the space, and that's okay. As long as you know it's going by 5s, you're okay. So while I have this bigger, let's take a look at where -30 would be. The -30 line is in between the -25 and 35. I'm going to go over to my axis of symmetry, and guys, 30 do the best you can. It's just going to be right below that 30 line, that -30 line. Once we start dealing with decimals, we're not going to get exact, and that's okay. So that's our -30. Slide over a little bit. There's our vertex. There's our vertex right there. Then our y-intercept, I know that comes out to be -28. So like, Miss Guy, -28 isn't on the y-axis. Well, it's in between, though, -25 and -30. So I do the best I can to put a point about where I think -28 would be. And that's all I can do. Once we start getting them where we have some decimals and we have to start changing our scale, we're not going to get everything perfect. All right, so this 28 is 1.5 away from the middle. So I go 1.5. Oop, I got to move my line. Away from the middle, and I try to line it up as best as I can. Now I have a nice curvy graph. And these are going to look a little bit, sometimes a little bit smashed down because we had to change our scale. If we don't have to change our scale, things look normal. But if we have to change our scale, sometimes they can look kind of smashed. Domain, as always, is all reals. Our range, our graph is opening up, so we're greater than or equal to. And it's the y value at the vertex. That hasn't changed. Same as what we did last unit with vertex form. So tons of similarities here. Tons of similar ideas. All right, guys, so far what we've seen is we've seen one in example 1 where everything works out perfect. We don't have to change a scale. We don't have any decimals. It works out perfect, and that happens. Then in the second one, we ended up with a decimal for a vertex, and we ended up having to change our scale. They don't always work out perfect, so I want to make sure we saw how to handle those decimals. If you go to the back side of your sheet, there's just a few that I wanted to make sure we went through. From more of the factoring standpoint than anything, I want to make sure we're solid on that. So as we look at number 3, the number in front of x squared, which is our quote-unquote a value, is positive. So we're going to open up. I left space under there, guys, so if you wanted to draw yourself what that means so we get used to that, it doesn't mean our graph necessarily shifts up. It's how it opens. So we know what it should look like. This is one I definitely wanted to go through today. This was the type that I got the most questions on yesterday when we were factoring. I'm going to write a little note here. No shortcut. No shortcut. And if you need to give yourself a little reminder why there's no shortcut, it's because we've got something other than 1 with our x squared. So no shortcut on that one. So we have to do our long way. So that means we've got to multiply 9 times 4. So we're going to multiply to get 36. And we're going to add to get 12. Now, a lot of you were doing this part yesterday, but then you still tried to shortcut it. I can't shortcut it because of that 9. So this one, 6 and 6 should work perfect for us. So then here's where we have to take those 6's we found and use them to split apart the 12x that's in the middle. Nothing else changes. I still have 9x squared and I still have my 4. A couple of classes ago, we refreshed on this and you guys made the choice if you liked the parentheses or if you liked the boxes. Either way, we'll get the same exact thing. So if we do parentheses, and I can show the boxes below in just a second. We can take out a 3x from the first one. We're left with 3x plus 2. And I can take a 2 out of the second one. And we're left with 3x plus 2. The two sets of parentheses have to match. And then we can go from there. So we have a 3x plus 2 left over, and then we also divided by 3x plus 2. I wanted to make sure we saw this example for 2 reasons. First reason being, we can't do the shortcut, so I want to make sure we saw one that can't be shortcutted today. And the second reason, I had a lot of questions on one like this yesterday. Miss Guy, what happens when you get the same thing twice? Is that okay? Yeah, that is okay. So if you get the same thing twice, guys, you only need to solve it once. You only need to set it equal to 0 once. If you're just in that habit of setting both sets of parentheses equal to 0, you can, but it's just the same thing twice. Don't put yourself through the extra work. Don't put yourself through the extra work. So what we end up with is negative 2 equals 3x. And then we divide by 3. Now this is one where we're going to need to leave it as a fraction. If you put that one in your calculator, you get a repeating decimal. Repeating decimals are hard to substitute in anywhere. So you're going to want to keep that one as a fraction. So let's think about this. Our x-intercept is, I can write it as an ordered pair. It's negative 2/3, 0. Negative 2/3, 0. That is in between 0 and negative 1. Let me blow my graph up here. Roughly right there-ish. It's not quite to negative 1. And I know the boxes aren't very big, so a lot of times our decimal stuff, it ends up looking like a half most of the time. Our boxes aren't very big. But now, to do my axis of symmetry, though, I'm supposed to add my x-intercepts together and divide by 2. How many x-intercepts do I have, though? I just have 1, right? What's the only point on our graph that doesn't have a matching point? The only point on our graph, let's take a look. I'm going to flip back real quick. The only point on our graph that doesn't have a matching point is our vertex. Our vertex point doesn't have a match. So when you come up with just one x-intercept, guys, you're going to love these ones because they don't take any work. That x-intercept has to be the middle of our graph. It doesn't have a mirror image. It doesn't have a point that matches on the other side. It doesn't have a match. So when you have just one x-intercept, you're done. You're done with the axis of symmetry. You're done with the vertex. It doesn't have a matching point. I can't add them together and divide by 2 to find the middle. It's done. It is the middle. It is the middle. So to get your graph, you have to rely heavily here on that y-intercept. And again, guys, make the y-intercept quick. It's just the constant. It's just the last number that doesn't have the variable. So we go to 4. And then we do our best. We're 2/3 away from the middle. So we go another 2/3 away. So we're right about at -1 1/3. It's a really skinny little graph. And that's okay. But if you only come up with one x-intercept, you're going to love those because all you need to find then is your y-intercept. If your x-intercept doesn't have a match, you found your vertex, you found your middle. Domain is all real numbers. We still open up, so our range is greater than or equal to. And in this case, it's a 0 at the vertex. So again, this example, for 2 big reasons. Reason 1, no shortcut to find intercepts. Reason 2, there's one x-intercept, so it's also our vertex. So all we can do is our x-intercept and our y-intercept, and that's all we can do to graph. And it's okay that it's a fraction, we're going to get those. We do as best we can to sketch our graph. Last but certainly not least, I wanted you to see one that will actually reflect for us. This one will open down. You might be like, Miss Guy, why is that important to know? Well, guys, I'd want to know what my graph is supposed to look like. So if I get my x-intercepts, my y-intercept, my vertex, and I graph, and my graph doesn't open down, and it should, I know I made a mistake. And picking out whether it opens up or down is super simple. No work required on our part. We just have to know if we have a positive or negative. That's really easy to pick out. Another reason I want to do this example is because I want to make sure I really hit home. And this was on the back part of your assignment yesterday, so I know some of us didn't get there. Some of us stopped after doing the first row because like, oh, we got it, it's easy. The first row in your assignment yesterday, you could shortcut everything. Then they got a little tougher as you went. This could have been a question on the back part of your assignment. I want to make sure I stress this to you because on your upcoming assignments, quizzes, tests, everything's going to be mixed up. I'm not going to group all the shortcuts together and then all the ones you can't shortcut and then all the GCF ones. Things are going to get mixed up. So we need to make sure we do GCF first. Always try it. As I look at these values, they can all be divided by 2. But more importantly, I'm going to go with -2. If you can divide by the number that's in front of the x squared, you're going to create yourself the opportunity to do a shortcut. So instead of having to do a ton of work, by dividing by -2, I have now created myself the opportunity to have just a plain x squared, and now I can shortcut. I've just created myself the opportunity to have a plain x squared. Now I can shortcut things. I don't have to do all the work to split it into 4 terms and do parentheses or do boxes. Save yourself a lot of work. Try GCF first. It won't always work. Sometimes we have to do the work like we did in question 3. But sometimes it will. And it's worth a shot. So I'm going to go ahead and shortcut this. Multiply to get 6. Add to get 5. 3 and 2 I think are going to be awesome for this. X plus 3 and an x plus 2. Don't worry about the -2 out front. That's not going to affect how we get 0. So we've got -3 and -2. Writing those as ordered pairs. Guys, I'm not going to, like on your last unit test, I'm not going to dock you points if you don't write them as ordered pairs. I just think writing them as ordered pairs helps give me that reminder that, hey, these go on my graph. And here's where they go on my graph. That ordered pair just helps give me a reminder. So we have -3 and -2. If you want to throw those on your graph, you can. They are super close together. And that's okay. Now, I know if you just look at this, we should be able to know what halfway between -2 and -3 is. But if you're not sure, add them together and divide by 2. So -5 divided by 2. Again, if you want to leave it as -5 over 2, if you want to write it as -2.5, if you want to do -2.5, it's fine. I'll take any of those. They're all great answers. But make sure you have the x equals. It is our axis. It is our line. So for the vertex, you know the x. Now you have to find the y. When you do this part, guys, you have to go back to your original. So we have -2 times -2.5 squared. Minus 10 times -2.5 minus 12. You have to go back to your original. Just so we don't forget about that poor -2. Go back to the original. It's going to be the easiest for you to enter things into. Go back to that original. So if we enter that in, and I'll put my screen back up in just a second, we have -2 times -2.5 squared. Then we have -10 times -2.5. Again, use the parentheses. Even the basic calculators have parentheses on them. The ones that I have up on my cart, they have a screen on them. You can see all that. Be careful with your negative signs versus your subtraction signs. Notice how the negative signs are raised up a little bit and they're smaller than the subtraction. So if we enter that in, I get -1/2. All right, so y is not -1/2, sorry, we get +1/2, don't we? Now here's where we have to be careful. Before we graph that though, what's our y-intercept going to be? Super quick, super easy. What's the y-intercept? -12, yeah. So before I graph that vertex, I need to make sure I can fit my y-intercept. This graph only goes to -10, so I need to change my scale to go by 2s. If you want to label every other line, that's okay. Or guys, to be honest, if you just label the first few, I'm okay with that too. Just as long as I can see that you've changed your scale. So if you just want to label, I just labeled like the first 3. I know by looking at that now the scale's going by 2s. So let's see, there's 12. I forgot to draw on my axis. Here it is at -2.5. So -12 is 1, 2.5 away. So we go 1, 2.5 on the other side. And then your vertex is just at 1/2. So that's going to be just this small little dot right above that x-axis. It's just going to be that small dot right above your x-axis. And then go ahead and draw your curve in. Whoa. The heck? Not sure where that other line came from, guys. There we go. There we go. Domain, you're looking at all reals, your range. This time we're reflecting down, so we're less than or equal to. The y value at the vertex is 1/2. Decimals are okay. That's the big reason why I wanted to make sure today. I know the lesson was kind of long today, guys. I get that. But I wanted to make sure you saw the different cases because I know for a lot of you, You're not used to graphing ordered pairs that contain decimals. You're used to the nice things like we saw in our very first example. But that doesn't always work out with our quadratics. That doesn't always work out. So the process doesn't change. You just might have some fractions to deal with or decimals, and that's okay.